algebra students. Today we're going to be working with polynomials again. And you can see up at the top it says that we're going to be solving polynomial equations in factored form. You don't know yet what factored form is. We'll be teaching you that in the next couple of lessons. But for right now, what we need to focus on is this thing called the zero product property. That just means, since it says it's a product, we're multiplying some things together and we get 0 for an answer. Well, you know that the only way that happens is if I was multiplying one of the things that happened to be 0 to start with. The only way to get 0 for an answer when I multiply is if one of the things that I was multiplying was 0. And we're going to use that to be able to solve some equations. And then, like I said, we'll get into factoring, and then we'll come back to this again after you've learned how to do the factoring as well. So in words, it says if the product of two real numbers is 0, then at least one of the numbers is 0. If I multiply things and I get 0, then one of the things had to be 0 to start with. So they even have this written in algebra right here. If these two things are real numbers and I multiply them together and I get 0 for an answer, then it had to be true that either the A was equal to 0 or the B was equal to 0. One of those things had to be 0 for us to get a 0 for an answer. So for this example, what you can see up at the top, that's what we call factored form. That's what we'll be working with soon. I've got x plus 1 times x minus 5 equals 0. So again, if I multiply those two things together, I don't want to FOIL those. I don't want to do a bunch of multiplying that way. I have factored form. I know that if I multiply x plus 1 times x minus 5 and I get 0 for an answer, then one of those two things had to be equal to 0. So you can see these equations that I wrote. Either this x plus 1 was equal to 0, or the x minus 5 was equal to 0. Now, up until now, every time we solve an equation, I need you to show work. On this, I would say, maybe you can do this in your head, right? So to solve this, showing our work, I would say, well, let's subtract 1 from each side, and that would give me that x is negative 1. I hope that makes sense, though, because you could have said, what number plus 1 gives me 0? Well, it had to be negative 1. The second answer has to be 5, right? Because what number minus 5 gives me 0? 5. The work would be this. X equals 5. So when I give you problems like this, you should start by writing those equations. I know you can do them in your head. I'm okay with that. But I need to see the equations. So my first equation in letter A would be x minus 1 equals 0. The second one is going to be x minus 2 equals 0. So those are my two equations. And again, now you should be able to do this in your head. If I say what number minus 1 gives me 0, or what number minus 2 gives me 0, I would get either 1 or 2. And again, you could show that work. And if you're a person that really likes to always do things exactly the same way and you just want to show your work because that's what you're used to, no problem. In B, again, I know right now some of you know the answers. I need the equations. I need you to be able to say that x minus 2 equals 0, x minus 3 equals 0. Those are my two equations. And then I could solve those either in my head or showing my work, adding 2 to both sides, adding 3 to both sides. I would get x is 2 or x is 3. Now, what I didn't show you yet is I could take the answers from any of these factoring kind of problems, these zero product properties, I should say, and substitute it in, and it should work, right? I'm not going to make 2 and 3 work, but at the same time anyway, because I'm only going to pick one number at a time. If I say that x is 2, and I put a 2 right here, and I put a 2 right here, 2 minus 2 is 0. 2 minus 3 is negative 1, but 0 times negative 1, that is 0. If I put 3 for the x, so 3 minus 2, that's 1, but 3 minus 3 is 0, and 1 times 0 is 0. So both answers work, and I need both of them. I need you to make sure that you are giving me as many possible answers as you can, not just picking one of them and just saying, oh, one's good enough. I would need to have both of those answers. All right, equations. X plus 7 equals 0, x plus 5 equals 0. When we have addition, you know to get rid of adding 7 on both sides, I would subtract 7 on both sides, or I would subtract 5 on both sides. And, or in my head, I would say, what number plus 7 gives me 0? What number plus 5 gives me 0? It'd be either a negative 7 or a negative 5. In letter D, I've got one that's addition and one that's subtraction. And still, it doesn't matter. I need my equations. X plus 6 equals 0, x minus 3 equals 0. And like I said, if you want to, feel free to do that. So you're going to get that x is negative 6 or x is positive 3. The first problem on this slide looks a little different because it's not two binomials, but I'm still multiplying two things. 2x is one of the things that I'm multiplying, one of the factors, and x plus 1 is one of the factors. So I would say either 2x equals 0 or x plus 1 equals 0. Well, 2 times what number gives me 0? That's 0. And what number plus 1 gives me 0? That's negative 1. In the second example, again, the first part that I'm multiplying is not a binomial, it's just x. So my first equation would be x equals 0. Seems strange to say that that's an equation because it looks like an answer, and it is. X equals 0 is one of the answers. And then 2x minus 8 equals 0. I would need to, at least at first, ask you to show some work on this. This isn't just a one-step problem. And I know some of you can absolutely do this in your head, but I'm going to say we should start by adding 8 to both sides, which would give me, and I'll uncover this all in a second, 2x equals 8, and divide by 2. So x equals 4. And there's all the work. So my answers, I had an answer up here, x equals 0, and then here's our other answer, x equals 4, that I'm going to uncover right there. They both work. I need both of them with the word or in between. Okay, these are getting to be, again, multi-step. However, I have a trick that I can show you in a second. But I would start by writing my two equations. 2x plus 7 equals 0, 2x minus 7 equals 0. Now, thinking about how to solve these, right there are the equations actually. How to solve these, I would start by, let me write it down here. 2x plus 7 equals 0. I would get rid of the 7. And then I would divide by the 2. And please remember, we are perfectly fine with improper fractions in algebra. You don't have to change that into negative 3.5 or negative 3.5 or any other way to write that. Negative 7 over 2 is fine. For the other equation, it just changes our sign. So negative 7 over 2 or positive 7 over 2. If you want the trick, here it is. The number that's getting added or subtracted at the end of the equation, so in the first problem, I'm looking at this plus 7 right here. When I move that to the other side, it turned into a negative 7. So I'm going to take that number and change the sign, and then I'm going to divide it by or make it into a fraction with the coefficient of the x as the denominator. If that made sense, because you have to move the number that's being added or subtracted and then you divide by the number with the x, you can save yourself a lot of time on this. So for instance, in this second problem, obviously we can see that the answer is 7 over 2, but I would take this and I would change the sign to a positive, because it'll move to the other side and become a positive, and divide by 2. 7 over 2 is my answer. In this problem, x minus 1 quantity squared, that means the whole thing is squared, it's in parentheses, equals 0. Well, if it's getting squared, that means that it's really happening twice. So when I write my equations, I would have x minus 1 equals 0 or x minus 1 equals 0, same equations. Obviously, I'm going to get the same answers. Both of the answers are 1. Now, here's the thing. I don't really need you to write the second answer. I don't need you to write it twice. I would not have needed, personally, for you to write x minus 1 equals 0 or x minus 1 equals 0. That's a waste. It's exactly the same as what you had the first time. I wouldn't need it twice. But I need you to understand that when it says it's squared, that's what's really happening. All right, in this problem, there are 3 different binomials that are getting multiplied together. So what I would have to do is start by saying each one of those could be equal to 0. So the x plus 1 could be 0, x minus 3 could be 0, or x minus 2 could be 0. And again, using our just changing the sign thing, we're going to be dividing by 1, so that won't even do anything. The first one should give us a -1, and then a +3, and then a +2. This says show the work if needed. If my trick made sense to you, you don't need to show work, right? I would still want to see the equations. I would still want to see for the first problem, 3d plus 7 equals 0, or, oh, not 3d, 5d minus 6. And again, my trick is change this sign so it'll be a -7 over 3. And again, change this sign so that'd be a +6 over 5. You can feel free to show that work if you'd like to. In the second problem, that w plus 4, realize that it's happening twice. Realize also it's not going to give us any other information by writing it twice. So I don't need to worry about that. But my equations would be w plus 4 equals 0. I could write again, w plus 4 equals 0. Or w plus 1 equals 0. -4, -1. This last problem is clearly the most difficult one that we've done. And notice that the m's are not the first part of each binomial. That can really kind of throw some people off. We still would need to write the equations. So 4 minus m equals 0. Before we move on, I would hope that you could say 4 minus what number gives me 0? Well, it's going to have to be 4, right? I could show the work and do this and say, oh, that's really a -1m equals -4. There's one answer. Second one, 8 plus 2/3 m equals 0. So I would have to subtract my 8, which is still doing that same thing of changing that sign. The issue is that fraction. I can't just make it a compound fraction, put that 2/3 into the denominator. I would want to multiply by the reciprocal. It will be negative. And feel free to use a calculator if you'd like. -12 for that one. And then -2 minus 3m equals 0. Changing our sign by moving it to the other side. And then dividing by the -3. So then m is -2/3. That was a messy one. We don't usually have problems that are that difficult though. So today's worksheet is 7.4. It's a zero product property. You are writing equations and telling me what makes each part equal to 0. When you're done, make sure that you check the answer key in Schoology and then take the formative. Let me know if you need any help.